the final page of the test review. So let's take a look at number 25 to 33. Number 25, this is a regular polygon, so we can safely assume that this is a square. So what I'm going to do is I'm going to create my central angle. So that means that, okay, if I do 360 divided by the number of sides, that's 4. 360 divided by 4 is 90 degrees, okay? So this is 90 degrees, and because this is from the center to the vertex, that's 9 inches, and then we can say the same thing for this segment as well, because it's from the center to the vertex of this square. So this is 9 inches. So now we have an isosceles right triangle. This is a 45, 45, 90 situation. So that means that this side here is 9 root 2. Okay, so now what I need to do is I'm going to use my formula A equals side squared. And you can look back at your notes for this one if you don't remember where this formula came from. So I'm going to replace the s with 9 root 2. So it's A equals 9 root 2, the quantity squared. So it's 9 times 9 times root 2 times root 2. So A equals 81 times 2. I need some more room here. So A equals 162 inches squared. This one is a regular polygon. So it's a regular, let's see, 1, 2, 3, 4, 5, 6 sides. It's a regular hexagon. So our generic formula that you have to use for a regular hexagon is A equals 1/2 the apothem multiplied by the perimeter. This is the apothem. It's from the center perpendicular to one of the sides of the regular polygon here. Okay, we know what the apothem, that's actually a given. It's A equals 1/2 of 4 root 3. But we don't know the perimeter of the hexagon. So what I need to do is I gotta solve for one of the sides here. And I'm gonna do that by creating a central angle. So from the center to 2 consecutive vertices here, we have a central angle. And I'm gonna go ahead and find the measure of this central angle. So the measure of that central angle is equal to 360 divided by the number of sides. It's a hexagon, so it's 6 sides. So 360 divided by 6 is 60 degrees. So this angle here is 60 degrees, and since you have this apothem here, it's going to split the 60 degrees into 2. It's going to bisect. So we can put 30 degrees here and 30 degrees there. We can see there's a 90 degree angle, so this is also 90. And then this has to be 60, that's 60. All right, so what do we know? If I draw one of the right triangles, we know that the apothem, let me redraw that again. So we have our 90 degree angle, and this is 30 degrees, and well, we already have the 90 degrees. Here's the 60 degrees. It's going to be right here. Our apothem is 4 root 3. And we're trying to find this side here, that bottom side. And we're going to label that as X because that's our unknown. So then what can I do here? Well, there are 2 scenarios. You can use special right triangles, or you can use trigonometry. And for my 9th graders out there, or possibly my 10th graders who want to do pre-cal for seniors, I'm going to do trigonometry. So what I'm going to do is I'm going to use this 30 as my angle of reference. And I'm going to write sine, cosine, tangent. Or you can use your mnemonic device here, SOHCAHTOA. And okay, let's label the right triangle across from the 30-degree angle. This is the opposite side. This is the hypotenuse, and then this is the adjacent side. So I'm going to highlight the two values, two numbers, or the two given that I need to, create my trig ratio, trig function. So I have opposites, I have adjacent, OA. So I'm using the tangent function. So I write tangent of 30, which is equal to my opposite side over my adjacent side. So to get x by itself, I gotta multiply both sides by 4 root 3. If x appears to be in the denominator, then you just need to swap the x and the tangent function with each other. But in this case, I'm just multiplying both sides by 4 root 3. All right, so I'm going to get my calculator out. And I'm going to restart my calculator so that we're all on the same page here. Whenever I'm doing trig functions, whenever I'm putting trig stuff into my calculator, I need to make sure that the mode is in degree. So if I scroll down, actually, there we go. If I scroll down, it's currently in radian. I need to get that into degree. I'm going to press second mode so I can quit that screen. And now I'm going to input 4 root 3 into my calculator. So 4 root 3 tangent of 30. So 4 root 3 times tangent of 30. So x is 4. It's not approximately 4. X is equal to 4, as you can see. All right, so I can put the calculator away. X is equal to 4. So this side is 4. This side is 4. So we can go ahead and say that this side is 8. So this is 8 centimeters. All right. And because it's a regular polygon, all the sides here are congruent to each other. So I just need to do 1, 2, 3, 4, 5, 6 times 8, and that's my perimeter. I'm adding up all the sides here. So 6 times 8, that's 48. And you should get, 1/2 of 4 is 2. So 2 times 48 is 96, right? So I did 1/2 of 4, 1/2 of 4, which is 2. 2 times 48 is 96. And then we can't forget the root 3 there. So it's 96 root 3 centimeters squared. That's my area of this regular polygon. All right. So now what I want to go ahead and do is look at number 27. I'm dealing with composite figures, shapes that are combined to form one figure. If we look at number 27, I'm dealing with two figures. I can see the two figures. 1, we have a rectangle. 2, we have a triangle. So I'm going to write area of this rectangle, and the area of a rectangle is base times height, and the area of the triangle is equal to 1/2 base times height. This is not an equilateral triangle, so I don't use s squared root 3 divided by 4. This is just a regular triangle. Okay, so let's find the base of the regular sorry, not regular. Let's find the area of this rectangle. I need the base, I need the height. Remember, the base and the height are perpendicular to each other if you have a parallelogram. A rectangle is a parallelogram, and we've already talked about that back in Unit 6 and also in this unit. So let's say that 12 is the base. It doesn't matter which one's the base or the height for this one because you're still going to get the same answer as long as you know that the two segments are perpendicular to each other. 12 and 10 are perpendicular to each other. So 12 times 10, that is, what's 12 times 10? That's 120. Oops, I just silly me. 12 times 10 is 120 centimeters squared. Okay, and then the area of a triangle, you have that 1/2. Okay, non-negotiable, and then you got the base times the height. The base and the height, they're supposed to be perpendicular to each other. All right, so we say that it's equal to 1/2. The base of this triangle is 12. And then the height, you have to create that segment. You have to create the segment perpendicular to the base of the triangle. Well, what is this length? Well, we know that this is 16. This is 10, so what's left over? It's actually 6, so it's 12 times 6. So 1/2 of 12 is 6, and 6 times 6 is 36 centimeters squared. Now you're probably wondering, isn't this the base and that's the height? Well, you can't assume that this is 90 degrees. Okay, yeah, you can see that these two segments are congruent to each other, but it doesn't mean that this angle here is 90 degrees. Plus, we don't even know how long this thing is, and we don't even know how long that thing is. So we can say that this is the base and this is the height, and they are indeed perpendicular to each other. All right, so I have this 120, I have that 36 there, so let's go ahead and combine those two figures. So the area of the rectangle plus the triangle, it's 120 plus 36. Your answer is 156 centimeters squared. That's the answer. Number 28. What are you dealing with? You are dealing with 3 semicircles. Let's just find one. So I'm going to find the area of the semicircle, right? And we're just going to find one, if you know what I mean. What I'm trying to say is if we find the area of one, there you go, then we can find the area of these two, because all we got to do is just take the area and multiply by 3, okay? And then what we have here is a parallelogram, just kidding. We have here a trapezoid. A trapezoid. Area formula for a semicircle, well, the area formula for a circle is pi r squared. But I'm dealing with a semicircle, so I got to divide by 2. For the area of a trapezoid, it's 1/2 b1 plus b2 times the height. All right, so let's go ahead and figure out the area of the semicircle. What's the radius of this one semicircle here? It's going to be 1.5. So it's pi times 1.5, quantity squared, divide by 2. And if I actually put this into my calculator, like exactly this, you're going to get 3.5. That's the area of the semicircle, right? And then let's go ahead and find the area of this trapezoid. So it's basically the two bases, right? So it's 1/2. This is a base, that's a base, so I have 6. Let 6 be B1. And then B2, what's B2? Well, you only see this 3 here, but those tick marks indicate congruency. So this is 3, this is 3, this is 3. So really, this thing is 9. So we have A equals 1/2 of 6 plus 9 times the height. Remember, the height is perpendicular to the two bases, which is 6. All right, so then what I need to do is I need to compute. So this is equal to 45. 45 square inches. Okay? All right, so once again, I'm dealing with 3 semicircles here. So I just do a semicircle plus semicircle plus semicircle plus the trapezoid. So it's 3.5 plus 3.5 plus 3.5 plus 45. And instead of writing 3.5 3 times, you can just say 3 times 3.5 and then slap on that plus 45 there. And then you get 55.5 square inches. That's the area of this whole figure. Now what I need to do is take a look at number 29. It says find the area of the shaded region. Remember, it's shaded minus unshaded. Shaded minus unshaded. Okay, so what two shapes do we see? We see a rectangle, so a rectangle, which is base times height. And then the other one is a circle. We actually have 2 circles here. So area of a circle, which is pi r squared. And we're going to say don't forget to multiply that by 2. All right, so what's the base? The base is 10. And the height is 5. So the area of a rectangle is 50 centimeters squared. So I'm going to highlight that and keep that in mind. The area of a circle, okay, we need to find the radius. So if this whole thing is 10, right, then basically this here, from the center to the circle, this has to be 5. If I cut it right here, this is 5 and this is 5. All right, so once again, this is 10. This whole thing is 10. And if I split it, this is 5, this is 5. So the radius should be 2.5. And you can look at it this way as well. So this is 5 centimeters, right? So that means that the diameter of the circle is 5 centimeters. Yes? So if I create a radius, well, what's half of the diameter? It's 2.5. So I can say pi times 2.5, the quantity squared, that's going to be 19.6. And yes, you will put this into the calculator. So it's 19.6 centimeters squared. So I'm going to highlight that as well. And we can't forget to multiply by 2 because we have 2 circles. So once again, it's shaded minus unshaded. So what I'm going to do before I put these numbers into this little formula that I created here, I'm going to multiply the 19.6 by 2. So 19.6 by 2 is 39.2. All right, so the area of two circles is equal to 39.2. So I really don't need this stuff anymore. It's this what I'm working with, and also that. So shaded minus, so the area of the square minus the two circles is equal to 50 centimeters squared minus 39.2 centimeters squared. Your answer is 19.08 centimeters squared. 19.08 centimeters squared. Okay. Now that we finished number 29, we can move on to the similar situations here. So for each pair of similar figures, find the following. Number 30, find the scale ratio from the unshaded to the shaded trapezoid. So when you're dealing with the scale ratio, you need to be looking at the one-dimensional objects. So these two figures are similar to each other, and this is a segment, and that is a segment. So I'm going from unshaded to shaded, so I can create a ratio between the two. So it's 10.5 divided by 15.5. And this is where you should use, math, enter if applicable. So let's do 10.5 divided by 15.5, hit enter, math, enter. Okay, we can say 21 over 31. That is my scale ratio. And now we're going to go ahead and find the area of the shaded trapezoid. So we have a segment here, we have a segment there. The area of the smaller trapezoid is 200 centimeters squared, but the area of the shaded region is actually our unknown. So we're going to call that x. So I'm going to do 21 divided by 31. This is my scale ratio, and I gotta equal that to my ratio of the two areas, which is 200 divided by x. All right, so the scale ratio is one-dimensional, like I said before. So this is one-dimensional, and this is two-dimensional because area is always, squared whenever we're writing our units. So are these two things proportional to each other? No, because, again, this ratio is one-dimensional and this ratio is two-dimensional. So you need to make them proportional. And how do we do that? Well, we're going to look at our one-dimensional right there, and we're going to square it. So what do we get? Let's move this over here so I have room. 21 squared is 441. And then 31 squared is 961, which is equal to 200 divided by x. Okay, so now we have 2D here, 2D there, cross multiply. So we're going to do 961 times 200. Whoa, that's a big number. And I'm going to divide that by 441. So you get x equals 435 point, we're going to round to the nearest tenth here, 435.8, okay? You can say 435.82 or 435.83. It really doesn't tell you to round, but if it tells you to round, be sure that you're following the directions. Okay, so your answer is 435.8 square centimeters. All right, so now let's take a look at number 32. It says find the scale ratio from the unshaded to the shaded trapezoid. All right, so look at this. This is not part of... Actually, I'm just kidding. This is 28. That's how tall the trapezoid is. So that is a segment, and that's one-dimensional. Over here, this is X feet tall. That's also one-dimensional. So is the scale ratio 28 to X? No, you actually need to have a number in the numerator and also a number in the denominator, so that you have an actual scale ratio. Okay? So this is not my answer, and I can't use 28 over X as my scale ratio. I need to look at two numbers. I can see that the area of the unshaded trapezoid is 296, and the area of the shaded trapezoid is 169. I'm going from unshaded to shaded. So let's do this. Let's write a ratio between the two areas there. So it's 296 divided by 169. And okay, let me see if I can reduce that with my calculator. 296 divided by 169. Enter, math, enter, enter. Okay, I can't reduce that, so I gotta leave it as is. So this is, a ratio, but it's not what I want. This is already reduced. It's the ratio of the two areas, and when you're dealing with the scale ratio, it has to be one-dimensional. Currently, this is two-dimensional, so I have to do what? I have to take the square root on both sides. So what's the square root of 296? Ooh. The square root of 296 is... this is going to be weird, but it's 17.2. And the square root of 169 is just 13. All right. That was kind of weird, and I can see that the key has 32 incomplete and 33 blank. So I'm just working with whatever the calculator has told me. So, and whatever the problem has given me. So the scale ratio is 17.2 divided by 13. All right. This is currently one-dimensional. So I write 17.2 divided by 13, which is equal to, okay, so 17.2 came from this 296. So this 28 should also be up top. So 28 over X. And I'm going to cross multiply. I have 17.2x equals 13 times 28. Let's divide both sides by 17.2. So I have x equals 13 times 28, which is 364. I'm going to divide that by 17.2, which is approximately 21.2, or you can say 21.16, or maybe you could say 21. It doesn't tell you to round, but let's just say 21.2 square feet. And there you have it.